picture this. You're driving down this completely unfamiliar stretch of highway, maybe heading out to a weekend getaway.
Right, we've all been there.
Yeah, exactly. And you glance down at the dashboard, and that battery percentage indicator for your EV is just dropping.
Oh, man, the worst feeling.
It hits 10%. Damn 5. You're frantically checking your navigation app, and there is just no charging station in sight, just miles of empty road.
And that's that classic dreaded range anxiety.
Exactly. But honestly,
Yeah.
that is old news. What's new and what we're looking at today is how the industry is actually solving it.
Right, and they're doing it in a way most people don't expect, not by, pouring more concrete or building more stations.
Yeah, but by completely unanchoring the charger from the grid. I mean, imagine if, instead of you frantically searching for a charger, the charger just came to you.
It completely flips the script on how we think about fueling our vehicles, doesn't it?
It really does.
Because for, over a century, the paradigm has been fixed. The vehicle goes to the fuel. Changing that dynamic, having the fuel literally hunt down the vehicle, is just a massive logistical and technological leap.
And that leap is exactly what we are exploring in today's deep dive. We are mapping out the rapidly evolving world of mobile EV charging and this concept known as charging as a service.
Which is a huge market right now.
Huge. And to figure this out, we are looking at a stack of new market forecasts from Future Market Insights and TechSci Research.
Yep.
We've also got a massive 10-year pilot study by AAA and some really fascinating white papers on commercial infrastructure from the Massachusetts Clean Energy Center and EO charging.
Really solid data in those.
Yeah, it is. Our mission today is to help you understand how this massive shift to EVs, and we're talking not just the car sitting in your driveway, but the delivery trucks dropping off your packages, how it's actually going to be powered.
Because the old model just isn't scaling.
It's exactly.
Okay.
Okay, let's unpack this. Because we always think of EV infrastructure as something bolted to the ground.
Yeah.
We literally compare them to gas stations.
Right.
So if EVs are the undeniably dominant future of transportation, why the sudden rush to, untether the plug?
Well, it comes down to a collision between the speed of vehicle adoption and the sheer physical reality of infrastructure construction.
Okay.
Before we even look at the billion-dollar commercial fleet industry, consider the everyday consumer experience. By 2024, global EV sales crossed 17 million units.
Wow, 17 million.
Yeah, that is over 20% of all new cars sold worldwide. So the vehicles are rolling off the assembly lines at breakneck speed, but the ground beneath them just isn't ready.
It's really lagging behind the sales. I was looking at that TechSci research forecast, and it referenced data from July 2024 showing the U.S. ratio of electric vehicles to public charging ports is a staggering 29-to-1.
Right. 29 cars fighting for every single public plug.
Which is, if you live in a rural area or you're on a long road trip, that density gap is a serious logistical hurdle.
And that reliability gap is exactly what necessitates these mobile solutions. When the static infrastructure fails or is just, too sparse, you need a dynamic backup.
Makes sense.
That is where AAA steps in. They've recognized that getting stranded with a dead battery is really the modern equivalent of running out of gas.
Right. You can't exactly walk to a station with a jerry can full of electricity.
Exactly. So they are currently expanding a pilot program to 16 metro areas, places like Orlando, Denver, San Francisco.
Okay, and what does that look like?
They're deploying specialized trucks equipped with mobile EV chargers, specifically to give stranded drivers enough juice to safely get home or, to a stationary charger.
Now, the press release on this rollout is fascinating because it mentions they actually started a prototype pilot for roadside charging way back in 2010.
Yeah, over a decade ago.
They ran it for 10 years, retired the original trucks, and are now using all those learnings for this new massive rollout. But I have to wonder, why did it take 14 years to scale this up?
Well,
in 2010, the battery density of a mobile charger must have been abysmal, right? They were probably driving around a massive, heavy truck just to deliver a tiny trickle of power.
Oh, absolutely. The technological limitations of the early 2010s were severe. You had these heavy lead-acid or really early lithium-ion batteries acting as the power bank.
Oh, heavy and slow.
Exactly, combined with very slow power transfer speeds. But today, Battery architecture has evolved dramatically.
It's night and day.
It really is.
Yeah.
And the portable EV charger market is booming right alongside this tech evolution. I mean, industry projections show it hitting nearly $232 million by 2031.
Wow.
Yeah, and we are seeing incredibly creative, lightweight tech emerge, like the GoSun charger.
Oh, I saw that in the notes. It's a solar-powered charger that literally folds out from a standard car roof rack.
Right.
I mean, think about that for a second. You drive your EV out to a remote campsite, you park it,
Yeah.
unfold the solar panels from the roof, and it generates enough power to add significant daily driving range entirely off-grid.
It's brilliant.
It's like carrying a portable power bank for your phone,
Yeah.
but scaled up to a 2-ton vehicle.
Yeah.
But I do have to push back slightly on the practicality of some of these consumer solutions.
Oh, how so?
Well, these portable chargers, especially the roadside assistance ones, are mostly level 2 AC chargers, and AC charging is inherently slow.
Yes.
If I am stranded on the side of a busy highway, I don't want to sit there for 3 hours just to get 10 miles of range to reach the next town, you know?
What's fascinating here is that the industry has run into that exact same bottleneck. To understand why it's slow, you have to look at the mechanism.
Okay, break it down.
When you use a level 2 AC charger, the alternating current power has to run through the electric vehicle's onboard converter.
Right.
It has to be changed into direct current, or DC, so the battery can actually store it. That onboard converter is really small, which completely bottlenecks the speed.
Gotcha.
DC fast charging, on the other hand, bypasses that middleman entirely and blasts power directly into the battery.
Which historically requires massive, expensive, heavy commercial hardware.
Yes, exactly. And that speed limitation of portable AC charging is exactly why we're seeing a massive, really fast pivot toward high-capacity DC fast charging in the mobile space.
Okay, so 3 hours for 10 miles is a major annoyance for me on a road trip. But for a logistics company running 50 delivery vans, that same math is, what, a total operational collapse?
Oh, it's completely unworkable.
So how are they handling this? Because we noted there were 17 million passenger EVs globally. But according to the data cited in that recent EO charging white paper, there are fewer than 4 million commercial EVs registered.
Right.
There's a huge gap. Why aren't the delivery companies and logistics fleets electrifying at the same pace?
Well, the barrier to entry for a commercial fleet is just an infrastructure nightmare.
How bad is it?
When you're a consumer, you can just plug your car into your garage wall overnight on a slow AC charge. But when you are a logistics company, you are managing industrial-scale energy needs.
You need that DC fast charging.
Exactly. And white papers from EO Charging and the Massey CC, they highlight the brutal reality of building permanent charging depots. It is not a quick weekend project. It can take up to 36 months just to get a facility upgraded.
Wait, 3 years? Just to be able to plug in your trucks?
Up to 36 months, yes.
It seems almost impossible for a fast-moving business to plan around.
It is. You have to factor in local permitting, massive supply chain delays for switchgear.
And switchgears are what, the heavy-duty electrical component?
Yeah, they're essentially giant industrial circuit breakers that route massive amounts of electricity safely. Plus, you have the heavy construction, trenching concrete, and the actual grid connection.
Wow.
And honestly, that timeline assumes you even own the land. Many fleet operators lease their depots. They legally cannot dig up the concrete to install million-dollar permanent chargers, and landlords are often hesitant to approve those modifications.
You know, if I'm a fleet manager in that position, my first instinct is to skip the depot entirely.
Really? What would you do?
I just give my drivers a corporate card and tell them to hit the public fast chargers at the grocery store or the mall on their route.
Okay.
I mean, it avoids a 3-year construction project and bypasses the landlord completely.
I see where you're going with that.
But I'm guessing the math on that lost time doesn't work out.
No, it really doesn't. If we connect this to the bigger picture, public charging relies on unpredictability. And unpredictability is the enemy of commercial logistics.
That's a good point.
The hard data from the commercial sector is actually pretty sobering. Around 1 in 5 public charging attempts fail.
1 in 5.
Yeah, due to broken hardware, software glitches, or connectivity drops. A family on a weekend trip can afford to detour to the next station, sure. But a delivery driver on a tightly optimized route, they cannot.
Plus, think about the physical footprint. If you've ever parked at a public charging station, the spaces are standard car size.
Right.
A 20-foot commercial docks truck physically cannot fit into a public parking bay without blocking traffic. And the charger cables aren't long enough to reach the port on a larger vehicle anyway.
The physical constraints are very real. But fundamentally, a fleet operator cannot afford the lost revenue of a driver sitting idle in a parking lot waiting in line for a charger to free up.
Time is money.
Exactly. It destroys their total cost of ownership.
Yeah.
When you factor in the hourly wage of the driver doing nothing, the missed delivery windows, the wear and tear of rerouting, the economics of relying on public infrastructure completely collapse for commercial fleets.
Okay, so they can't wait 36 months to build a permanent depot. They can't legally dig up their leased parking lots.
Yeah.
And they can't use public chargers?
Nope.
It sounds like the entire logistics sector was essentially trapped.
They were trapped. Until the market developed a bridge. And that bridge is mobile charging as a service. It transforms EV charging from a massive, multi-year construction project into a flexible monthly subscription.
And the numbers tracking this shift are staggering. Market forecasts project the EV charging as a service market, or CAIS, will explode from $2.6 billion in 2026 to $16.8 billion by 2036.
It's massive growth.
And 55% of that revenue is driven purely by subscription or pay-per-use fees. Fleet managers don't want to be in the business of buying and maintaining electrical hardware anymore. They just want to subscribe to the energy, like a software service.
Right, it is an asset-light model for the fleets. Instead of sinking capital into physical infrastructure that might be obsolete in 5 years, they partner with companies that bring the power to them.
Like who?
Consider companies like SparkCharge. They recently raised over $30 million specifically to expand their mobile network coverage.
Oh, wow.
Yeah, they deliver turnkey charging subscriptions that guarantee uptime. The fleet manager pays a flat fee, and the provider ensures the trucks are charged and ready every morning.
And the hardware enabling this is just mind-blowing. The MassEC presentation detailed some of the tech they're funding to help fleets in Massachusetts.
That EXO, right.
Yes, the Exos Hub. It is a massive mobile energy storage system on wheels. It holds a 280 kilowatt-hour battery and has 4 charge heads that can output 160 kilowatts of power simultaneously.
Which is huge.
And the best part, it literally takes up just one single parking space.
Yeah.
And it requires absolutely no connection to the local power grid.
Yeah.
You tow it into the leased parking lot, drop it down, and you have an instant commercial-grade fast-charging depot.
And we are seeing that critical shift from slow AC charging to ultra-fast DC charging in the mobile space across the board.
Yeah.
Companies like Pioneer Power Solutions are rolling out mobile platforms capable of providing between 180 and 500 kilowatts of independent power.
500 kilowatts.
Yes. That is enough to fast-charge heavy-duty commercial trucks, and it completely bypasses the 36-month delay for grid upgrades because the power is stored in the mobile unit itself, which can be swapped out or recharged off-site.
Okay, here's where it gets really interesting. Because we aren't just talking about big battery trailers being towed into depots.
Definitely not.
In the industry intelligence reports, they highlight a company called Ion and Dynamics that unveiled something called the FlashBot.
I love this one.
It's incredible. It is an autonomous mobile EV charging robot. It navigates parking lots entirely on its own to charge vehicles on demand.
Right. It essentially functions as a mobile-level 3DC fast charger with self-driving capabilities.
Unbelievable.
It uses sensors and cameras to hunt down the specific vehicles that requested a charge, connects itself, and then moves on to the next one.
Just imagine how this impacts you directly. You drive to a crowded grocery store on a Saturday. You don't have to circle the lot fighting for that one dedicated EV parking spot by the front door.
Because the charger comes to you.
Yes, you just park wherever you find a space, tap a button on an app on your phone, and while you are inside navigating the produce aisle, this little autonomous robot rolls up to your car, plugs in, charges it, and rolls away before you even check out.
It is a brilliant solution for commercial property owners as well. A mall or a grocery store doesn't have to spend a fortune trenching thick copper cables through acres of asphalt to install fixed chargers. They just deploy a fleet of robots.
Problem solved.
But this raises an important question. Having mobile hardware and autonomous robots is a great physical solution, sure. But as these commercial fleets and consumer networks scale up to thousands of vehicles, managing all this distributed, moving energy becomes a logistical nightmare.
Right. It's not just about having the battery on wheels. You have to orchestrate exactly when and where that energy is deployed. Otherwise, you have, robots wandering aimlessly or dead batteries at 5 a.m.
Exactly. The physical hardware is only half the battle. The real magic, the mechanism that actually makes this viable for a massive logistics company is the software layer.
Okay. How does that work?
According to the EO charging white paper, fleet operators require what they call charge assurance.
Charge assurance.
Yes. because internal combustion fleets currently operate with near 100% fueling reliability. You turn the key, the diesel engine starts.
Right.
If an EV fleet is going to compete, operators expect greater than 99.5% uptime from their charging network.
Which is incredibly hard to do when you're dealing with the power grid, software updates, and human error.
Mhm.
I mean, think about all the times your home Wi-Fi just inexplicably drops.
Exactly.
Now imagine that happening between a charger and a delivery truck that needs to be loaded in an hour.
Right, it's catastrophic. To hit that 99.5% reliability mark, you need intelligent software running constantly behind the scenes. One of the most striking statistics from the EO charging data is that 47% of system faults can be rectified automatically by self-healing software.
Self-healing, I mean, I'm picturing a sci-fi movie, but how does a physical charger actually fix itself without a mechanic?
It's actually pretty straightforward. Chargers are essentially large, high-voltage computers.
Yeah.
When you plug an EV in, the car and the charger perform a digital handshake to agree on voltage, battery temperature, and charging speed.
So they talk to each other.
Exactly. Often, a fault is just a timeout in that handshake. Maybe a slight voltage fluctuation from the grid caused the communication to stall.
Ah, yeah.
Instead of a human engineer driving out in a maintenance truck to look at it, the self-healing software detects the digital stall. It automatically runs diagnostic protocols, restarts the handshake, reboots the internal systems, or reroutes power flows to restore service instantly.
Wow. So it turns a potential multi-hour maintenance delay into a 2-second blip that the fleet manager never even sees.
Yep.
And they need that level of absolute software control because they're dealing with physical constraints that are just mind-boggling. I mean, look at the case study in the EO white paper about the Stagecoach Romford bus depot in London.
That is a perfect example.
They had to electrify a massive fleet of around 100 city buses, but they had zero floor space to spare for bulky charging pedestals. And on top of that, severe limits on how much power they could pull from the aging London grid during the day.
It is a classic urban electrification bottleneck. Real estate in London is far too expensive to waste on infrastructure footprints, and you cannot just drop a dozen fast chargers into a crowded depot without catastrophic consequences for the local power grid.
So to solve the space issue, they installed 9 ceiling-mounted cable reels. The chargers literally dropped down from the roof to plug into the buses.
It's so clever.
And to handle the grid limits, they use a software platform to actively load balance the power.
Right. Think of the depot's electrical capacity like water pressure in an old house.
Okay.
If every single bus tries to pull maximum power at the exact same time, it's like turning on every shower, sink, and outdoor hose simultaneously. The pressure plummets, and in electrical terms, you blow the local substation. Exactly. So the load balancing software acts as a smart valve. It dynamically routes the electricity only to the buses that are completely empty, while throttling back the flow to the ones that are almost full or, don't have a route until the afternoon.
Plus, it actively schedules the heavy charging for off-peak hours in the middle of the night when electricity is cheapest, which saves the depot an absolute fortune in energy costs.
That level of intelligent control is mandatory. At scale, a commercial fleet becomes an industrial consumer of power.
Yeah.
And once you have that software acting as the smart valve, it opens up entirely new, highly lucrative business models. For example, depot sharing.
Oh, yeah. There is an initiative in the UK testing this right now called PNS, the Private Infrastructure Network Solution.
That's the one.
If you think about a delivery fleet, their trucks are out on the road making deliveries all day long, which means their massive high-speed charging depot is sitting totally empty for 10 hours a day.
Right, and depot sharing allows that private business to open their charging hub to other commercial fleets during those off hours.
So like a bakery fleet could charge their vans at the logistics depot while the delivery trucks are out.
Exactly.
It sounds like charging networks are becoming less like traditional gas stations and more like cloud computing.
That's a really good analogy.
Right. It's virtualized, it's shared, it's highly utilized, and it's managed by IT help desks running self-healing software that fixes bugs before the user even knows they happened.
Yep. You are turning a cost center into a profit center simply by utilizing software to manage mobile and stationary energy assets dynamically.
So what does this all mean for you? The next time you see an electric delivery truck silently gliding through your neighborhood, or when you're thinking about the infrastructure supporting your next EV, realize that you shouldn't just be looking for a static plug in a wall.
Definitely not.
The future of energy isn't bolted to the concrete. It is mobile, it's subscription-based, and it's highly, highly intelligent.
The transition to electric vehicles is forcing us to completely decouple the concept of fuel from a specific physical location on a map.
Which leaves you with a pretty wild final thought to mull over. If charging hardware is becoming entirely mobile, if we have autonomous robots navigating parking lots, and massive battery hubs that can be dropped anywhere without a grid connection, all managed by self-healing software,
Yeah.
will the traditional concept of the gas station or the charging station eventually go completely extinct?
It's a real possibility.
Imagine a future where you never have to go get fuel again. The grid is entirely decentralized, and the energy physically hunts your car down wherever you decide to park it. Thank you so much for joining us on this deep dive. Keep exploring the unseen systems that power your world.